All right, so if you're on, I think, page 77, there's an integration techniques guide. So, this integration techniques guide is kind of I don't know what to tell you at this point. There are people that have done enough of these where all of these things are burned into their brain already. Those are the people that probably don't need this. The ones that haven't bothered to do the homework are probably ones that won't learn this. Well, so I don't know if it's super helpful or not, but at this point, if you're struggling with your rules or even what to do, or you're like, man, I didn't even think to do that, or I didn't think to do this. This is kind of kind of a map to getting stuff done in here. And I think one day I sat down with a whole bunch of random problems and just started working them. And whenever I actually thought about something, I added it to the list. And then I tried to clean up a list in a way that would actually be user-friendly to you. So this is kind of my brain's approach to any single problem that I see when something obvious is not in play. So like you just took your quiz. If you got all these problems right, then these are obvious questions to you. You didn't need this help. But when you get stuck, this is a good kind of a plan of action. So my brain, typically I'm looking for power rules. So if I can look at a problem and go, oh, this is a power rule problem. Great, apply your power rule, get done. You see a whole lot of this in the problems that you do in physics, maybe if you're doing integration stuff in physics, position, velocity, stuff that we'll do in the future. A lot of those are like parabolic movements, like if we're throwing a projectile, you'll see a little parabola, quadratic equation. A lot of times you see stuff like that. If that's not obvious, then like your quiz you just took, do the U substitution to make it look like something that you recognize. And then you apply the power rule or whatever rule that you're dealing with. And these two are probably the most common integration problems that you see moving forward when you're not just in a math class where we're really testing integration for the sake of integration. For the sake of testing you. Most of the time there are situations like this. So, what do you do when these are not quite as obvious? Well, here's an example that shows up a good bit. I look at number 3 and I see a power rule problem. Because when I have a monomial on the bottom, I can treat that monomial like either one of two things. Whether it's a square root of x or whether it's an x squared, I can place it beneath each one of these, and then I have like bases on my variable. And we know that to divide with like bases, you do what? Subtract the exponents. So I can go 3 minus a half, 2 minus a half, 1 minus a half. And that should be, yeah, that's still half. And then I've got a power rule that meets the conditions of step number 1. Okay? Now another thing I could do, and I had somebody mention this in either this class or the other class, they treat the root x on the bottom as an x to the negative 1/2, and then they just distribute it in. And in that case, they're multiplying, and what do you do when you multiply like bases? Add exponents, but you've made it negative, so when you add it, it's the same thing as subtracting it if you are thinking about it as division. The next thing I do is, what happens when you have a fraction? And this rule would actually apply if you have a fraction, or if you have maybe a square root in your problem. Typically, and we've talked about this, when you're doing the U substitution, typically we want to actually do what?
Long division.
Well, normally we typically want to grab the one with the highest power as my U, because then my du ends up being a lower power, right? But that doesn't work here, because if I grab this as my U, my du needs to be coming from the denominator. But if I just take the derivative of that, I get a 3x squared. That's a numerator value. So it doesn't take care of this. So one of those things that needs to pop up on your radar is when you see a fraction and the highest power is not on the bottom, which means the highest power is either on the top or the powers are equal, then do long division. And if you forgot long division, you'll have to ask me about that, and we can work on it later if we have any free time. And after my long division, remember when you divide, you end up with a bunch of monomials, right? And then a small fraction. And remember, when you finish dividing, the numerator in your fraction is now always going to be smaller than the denominator, because that's what happens when you change from a mixed number to a mixed number to an improper fraction. These are technically improper fractions. Now I can integrate each part. And a lot of times that last integral ends up being a what? It's a u substitution, and it ends up with one of those 1 over u, so a natural log. So you end up with a natural log. I didn't do the math on this, but you end up with a natural log at the end of these a lot of the time. And then just a bunch of little power rules. All right? And then also when you have fractions, and fractions are really the source of most of your problems when you're integrating fractions. You're integrating fractions like this, where you have to combine these terms. That's a monomial. Integrating fractions with powers bigger on the top are the same as the bottom. And then you're also integrating fractions that have the inverse trig results, right? And I gotta be honest, if I saw this problem, my first thought would not be inverse trig function. My first thought, even if it might be a split second thought, would be u substitution. I would think, oh, I'm gonna make that whole thing on the bottom u. But the problem with that is if I make that u, what is my du? If that part on the bottom is u, it would be negative 8x dx, right? I would love it if it was negative 8 dx. I could put negative 8 dx. But it's negative 8x dx. I can't put an x there and a 1 over x there to fix it. I can't do that with variables. Does that mean it's the end of the world? No, it means you go to this sheet and go, all right, what other situations do I run into trouble with fractions? It's not a long division problem because I have no idea how to divide that into something. So maybe it's one of these inverse sine, inverse tangent, inverse secant questions. And this one fits the mold of an inverse sine, right? All right? And if there's no square root and it's plus, then it very likely could fit the mold of an inverse tangent. Or if it's the x squared's in front here and you're subtracting like a 36 and there's an extra x out front, then it might fit that inverse secant mold. But again, you have to know those rules well enough to see if you can get it to fit. And in this one, look, I was able to get it to fit. All right, and then the last thing is that if everything else is failing, you've tried it all, right? And you're just like, I don't know, I've tried inverse stuff, I've tried u substitutions, everything is falling apart on me. Then remember, as a last resort, that ugly u substitution, like the one I did right before you got started on this, that ugly u substitution sometimes works. And again, ugly u just means when you pick a u and du and you make your substitutions, what happens? U, negative 1, du, there's still going to be some other variable hanging around that you haven't replaced. And when that happens, then say, all right, I'm going to solve that for x, add x, subtract u, and I'm going to put that in for that last x there. And then when you do that and you replace everything, now you just have written it in a different way. And the advantage of this now is I have a monomial under the radical, which I can distribute in. And again, this is not the calculus. When you finally get it to here, that was all to get it to where you could apply the calculus. Because it's all about making it look like one of your rules. Go with me? Now, I hope that everybody in here is like, you're repeating yourself. This is child's play. I really do hope that. But every year I have this same conversation and people are really quiet. They're like, yeah, I know, I got it, move on. But then they get to their test and it's very clear that they either A, didn't do any homework, or B, didn't check what they were doing, which is bizarre to me. I don't know why you'd even bother doing homework if you're not going to check it. Why? I'm not taking it up. You're either A, reinforcing negative behavior. You're literally doing it wrong so many times that now you firmly know how to do it wrong. With confidence, I'm confidently wrong, but you don't know it. Yeah, you got to check your work, make sure you're right. And guys, don't assume that anything you get wrong is careless. I mean, it might be, but if you keep consistently missing a fraction, it's probably that you don't understand u substitution like you think. Come in here for 5 minutes. Ackman comes in here like every other day. Probably one of the people who needs it the least. And you just ask a simple question, he's like, oh, good, and then walks out. Takes just 1 minute every day. It's no big deal. I'm hanging out in here, wishing I could help someone. All right? So please take advantage of that. We've only got 3 or 4 minutes, but don't just sit and stare at it. Oh, this innovation by parts, we're not doing that. It's not an AP topic, so that was extra anyway, but it's not on any of your work. I think that I've gone and omitted it from most of the problems that we do. If you happen to run into one and you're like, what the heck is that? If you see, hey, let me just say this. If on any of the homework problems, you don't know how to do it, and you look at the key and you see this, if you see like a U, DU, and then you see this V, let me write it where you can see it up there. If you see like a U and then a DU, which that's pretty common, right? But then you also see a V and then a DV. If you see something like that, that's an integration by parts problem, just skip it. I think that I've omitted them all, but I might have missed one or two. So if you see anything like that, you're like, what the heck is he doing? Don't worry about it. It's not an AP topic. You would have to learn it in Cal 2 when you go off to college, if you have to take that. All right? All right, guys, make sure you're doing this homework this week. This is just a huge review week for you. A chance to really make sure you get this stuff down. I don't have anything new to offer you. And when else are you going to get a 4-day review for a test? Never. Not even exam week. I only give you 2 this year because we're out of time. Yes?
Do you have
the textbook?
Oh, the textbook? Yes.
Can I have the exam packet?
Yes. And remember, guys, the keys to your exam review packet are on Schoology already for you to start checking and correcting if you decide that's a good idea.
Are you typing them up?
No.
No, I didn't.